Okay, this is a recording of the NanoTape. I'm going to switch the material on so you can see what it looks like. So, just gives you a rough idea of how this thing looks. This is actually 45 millimeters across the width, and the thickness is roughly around 2 millimeters. And what I've got here are, I've used 9 side view red LEDs. These are very low power. These are 30 to 50 milliwatts each. So I'm putting actually around 30 milliwatts in each one, which is actually very low power. The problem I've had with these tiny little LEDs is getting the right printed circuit board. This is actually made up by hand. This is a breadboard. And as you can see, the light going into this waveguide, this flat tape, isn't as good as it would be if it was properly coupled, i.e. that the LED's output phase is in direct contact with the input phase of this material. This is actually 1 meter long. I don't know if the camera can actually see that, but I've got it laid out across the table. What's interesting about this material is it's got a very high surface energy. In other words, that allows it to adhere to things like paint and inks, for example, silk screen printed inks or UV printed inks. You can even laser etch onto this as well, which is really nice, and you get a much nicer effect on there. You get very nice bright spots. Any imperfections and fingerprints, for example, bits of foreign bodies that have been accumulated onto the surface show up at these very white, bright spots. But obviously, I've only got a red LED connected to this particular length of material, NanoTape 45, which is the 45 millimeters wide. But you can obviously have any color. You can have green or blue. You can have full spectrum. If you have red, green, and blue LEDs, you can mix the colors accordingly. And this material serves as a very nice mixing medium, so you end up with full spectrum kind of effects on this. Very nice. And this is the NanoTape, and this is a 1 meter long piece of material. The next thing I'm going to show you is the NanoFibre, which is a 2 millimeter NanoFibre 20. So that's the NanoFibre 20 video. So this is a video of the NanoFibre. This is 2 millimeters NanoFibre. As you can see, I've got roughly around, I don't know, maybe 20 strands bundled together, and I've got 4 LEDs at the bottom of this small cluster. These are roughly around 150 milliwatt LEDs, 4 of them, and I've powered them with 3 1.5 volt batteries in series. It's a total of 4.5 volts. These are AA batteries. Sorry, these are AAA batteries. Sorry, same voltage, 4.5 volts. I've limited the current to roughly around 80 to 90 milliamps through each of these LEDs. So it's a very low current drain and also low power consumption. The length of these fibres are actually 300 millimeters long, 30 centimeters, and you can see it's got quite a considerable end light. If I bunch them all together and spread them out, you can see how nice they look. So you've got very effective side emission, radial emission of the light, and also quite considerable end light. So the light is actually propagating down the length of the fibre, undergoing total internal reflection, and as the light travels, it encounters the nanoparticles, which are trapped inside this resin, inside the matrix of the polyurethane resin itself, and you end up with this fantastic side emission. Now, the transmission length on these individual fibres in the red part of the visible spectrum, this is a 625 nanometer red, which is kind of bordering on the orange. You'll get roughly around just over a meter if you couple it correctly. So obviously this one has just got LEDs on one end, but it's better to have, if it's longer than this, to have LEDs on the other side. You get a more balanced light distribution in the length of the material. Otherwise, the intensity tails off with distance, with length. So anyway, this is just a demonstration on a cluster of roughly around 20 strands of 2mm nano fibre, and I'm gonna connect up the green strands, 1mm strands, same length, big bunch like this, and I'm going to see what that looks like. So yeah, over and out. Cheers.